So in the previous video, we talked about the basic concepts and the origins of the virtual desktop infrastructure. Another way of saying this is the problem that virtual desktop infrastructure is trying to solve. Putting the right kind of desktop in front of the right people at the right time in the right place. Without having an inordinate number of physical computers doing not much of anything most of the time, which is honestly, I mean, we're basically taking the the impetus for server virtualization, which is of course where virtualization started. A lot of our most interesting technologies begin in the laboratory or in the server farm, and then once they develop to maturity, past the point of to the point of cost effectiveness for end users, they escape the laboratory, they escape the data center, they become normal for us. So anyway, the problem we're trying to solve with server virtualization is I have a bunch of computers and they all have one operating system and they're all doing a whole lot of not much most of the time. And that's cost ineffective. That is expensive and wasteful in a lot of different ways. So let's take all these server VMs and put them in one place. And boom, server virtualization. Now we can do the same thing, particularly now with very fast networks. Now that you can get, and let me show you this. I'm going to do a little bit of compare and contrast here. This is a bitty little Raspberry Pi. It is a system on a board, and it has a gig. It has a 1 gig NIC. You can also see it's got itty bitty processor, and some other stuff. In any case, my point here is this little thing, which is very, very inexpensive, effectively so inexpensive that it is practically disposable, not that I plan to destroy it, has more networking power than this thing. This is the Linksys dual speed. Is it a dual speed hub? It may not even be a dual speed hub. This is the Linksys hub that I started to learn networking with 20 years ago. It's got 8 10 megabit per second ports on it with an uplink port and literally a thin net BNC connector on it. So if you wanted to tie it into a true Ethernet, it's a hub. It's dumb. It does everything by broadcast. Slower than Christmas, infinitely slower than this thing here, and that's how far computing has come in my lifetime. Anyway, so we're moving now. We have the ability to move these things around in the network very, very fast. Lots of compute power everywhere, but maybe not the right compute power everywhere. That's the problem we're trying to solve. The challenge that comes with solving those problems, there are a number of them. Particularly in small VDI implementations, some of these problems don't impact you as much. But in a large-scale implementation, if you have thousands or tens of thousands of users, you are really going to have issues with things like storage space, load balancing across the hosts that are supporting those virtual desktops, your application management. Because just as you don't want to have a bajillion physical machines, there's really no good reason to have a bajillion virtual machines with precisely the same configuration. And if you have to make a configuration, it would be much better to make that change in one place than in many places. That's why we have things like DHCP and DNS. Then fault tolerance. How do you, I mean, with a system with lots and lots of moving parts, inevitably one of them will break. More than one will break. How do you eliminate the single point of failure? How do you make sure your users can get to their virtual desktop without really needing to care where it's hosted, where it's stored, all of that. So the first of these problems is storage, because we're talking about we need to have a storage location that makes the virtual desktop location agnostic. It should not care what host it's living on. Ideally, you'll have a whole bunch of practically identical host ESXi hosts or Hyper-V servers. Now, you can solve some of the storage problem by having linked clones or differencing disks, so that instead of having a full VM for every single one of your employees, if you have a base image, a parent, and then the mechanism by which to tailor that parent to that image, that linked clone, that child device, the child image rather, to the target end user, you can save yourself an enormous amount of space. Instead of having 40 gig image times 1,000 employees, you're talking about terabytes or petabytes of storage. You can have a single 40 gig image and a whole bunch of slight differences. You deploy that and you go. Now, another option, in addition to our linked clone differencing disk feature, is the instant clone desktop. Hyper-V calls this a pooled virtual desktop. Basically what you'll do is you've got a master, a template, on the host hypervisor, and the system spins it up as needed. This doesn't take any extra disk storage because these things are non-persistent. That's another thing you can do to manage your storage. Decide on the basis of what kind of user you're supporting whether that needs to be persistent or non-persistent. And non-persistence is actually one of the features that makes virtualization so powerful. We still want to keep, we still want to be good stewards of our users' data. But if any given object just kind of stops working, okay, clone it, snapshot it, replace it, keep going. Now, one of the other things we have to think about here is load balancing. Because while our goal is to increase the utilization of every host, the goal is not to maximize the utilization of every host. We still need, on the basis of application and user requirements, to keep host CPU and memory utilization below that 60 to 70% range. If it's running above that range, that indicates that you're working that system too hard, or you haven't given that system enough resources. Now, if you can solve this problem by populating a second CPU slot on the board, great. If you can solve this problem by filling out your banks of RAM, great. You've made the whole system more useful. But if that same system is at the limits of its capacity, then if you see consistent utilization that high, then that tells you you need to move some of that load to another system. We also need to monitor host memory and CPU utilization. That is something you can do locally in the ESXi web console, but because we're already going to have to use, say, vCenter for our infrastructure for VMware Horizons, you could do the same thing in your vCenter web client. Watch all your hosts in a given group or cluster or data center. Watch the ones, and you are also going to, so like I said, create a baseline, watch your utilization, adapt to changes on the fly. You can do some of this automatically with DRS, the Distributed Resource Scheduler. Distributed Resource Scheduler can do something as complicated as just move the host for you, move the VM to a new host for you, or query or alert you or prompt you to do a manual move using vMotion. Now, this is another reason we need vCenter, because we're dealing with clusters of hosts in data centers, and vMotion. All of this load balancing stuff is not possible if all you can do is a cold manual migration. That's not load balancing. That may be good planning, but it's not effective load balancing, because the only way to do it is to create downtime for your customer, and your users hate downtime. Just take that as a given. The user hates downtime. Now, the other thing we can do with this is fault tolerance and high availability. Fault tolerance and high availability are almost the inverse, the other side of the coin, as far as load balancing are concerned. You may load balance to make sure to optimize performance. You can also shift hosts between systems to make sure that if a given host in the cluster has failed and needs to be replaced, rebuilt, troubleshot, etc., you just move things and keep rolling. Both VMware and Microsoft offer these options, and we'll explore them in due time. We can also provide some fault tolerance using the networking features we know about. NIC teaming, having multiple physical switches, multiple physical NICs on a device, multiple ports on a given NIC, having multiple virtual switches, multiple virtual switches, multiple physical switches, all the stuff you've learned about in your networking classes about about redundant network design still come into play here. The other thing we can do, you need to think about, is user data management. Roaming profiles are a key concept here. Roaming, if you think in terms of roaming profiles on a Windows Active Directory, that's a great idea here, so that wherever your user logs on, they have the same desktop, they have the same data, etc., etc. So that it doesn't really matter which virtual desktop you hand them, because you're also handing them your data, their data rather. You can do this in VMware using user environment management. We can also do application management, as I mentioned, because your users are accessing these virtual desktops for the sake of getting something done. They're going to need applications. Now, granted, a lot of what we do now is with web applications. So some of your users might just need the right browser, the right plugins, the right links. Some of your users might need something a good deal more complicated. We can provide application virtualization just as we can apply platform virtualization. This allows you to package an application, isolate it from the OS, basically applying virtualization up one more stage. So you can you can tie your apps to your users. You can deploy the app to the user, to the desktop, without actually having to build the app into the desktop. VMware has two different ways to do this: vApp and ThinApp. Microsoft offers us Remote App and App V. We might also be we're almost talking about containerization here. Things like Docker. This allows us to make sure that all our users have the right load on their systems. So that covers some of the challenges and features of the virtual desktop infrastructure. The next thing we're going to do is talk about products, specifically VMware Horizon, and we're going to spend the next several videos on VMware Horizon. So thanks for watching.